Okay, so in this question here, we're asked to use the substitution x equals 2 sine theta. Okay, so of course, first thing we need to do then is obviously we're going to replace all the x's in this integral for thetas, essentially, right? So we're going to have to replace the dx, so I'm going to differentiate. Now you've got x this side, theta that side, so we're going to do dx by d theta. Okay, if I differentiate 2 sine theta, I get 2 cos theta. Alright, and then what I can do then is to get dx, because I want to replace dx, take the d theta up there, and I've got my dx. Okay, taking it up there, as simple as that, we're done. Alright, now we need to change the limits as well. Remember, these limits are in terms of x, okay, so that's x equals 0, isn't it? And that's x equals root 2, because all of this integral is in terms of x. So I need to get what those values are in terms of theta. So if I put it into my substitution, okay, then I should be able to work out what the limits are. So if x is 0, I put 0 here, yeah? So 0 equals 2 sine theta. Of course, then with the 2 then, you know, I could take it over and divide. And 0 divided by 2 is 0. So that implies, of course, sine theta is just 0. Okay? And of course, to get theta then, you've got to do sine to the minus 1 of 0, which of course is just 0. Now, we've got then root 2 equals 2 sine theta for the upper limit. So that implies then sine theta equals root 2 upon 2. Okay, so you take that 2 over and divide. To get theta then, you do sine to the minus 1 of this. And do that on your calculator, you get a pi over 4, right? Make sure it's in radian mode. It's got to be in radian mode. So my integral then, I, becomes, my limits are 0, pi over 4. Now x squared, right? Can I get x squared? Well, I know x is 2 sine theta, so all I've got to do is square that. All over then, square root. 4 then, take away. Now it says x squared again, so again, square that. And then times dx, okay? And dx, of course, is all of this here. 2 cos theta, d theta. All right? So, if we then simplify this integral, square that, of course that becomes 4, that becomes sine squared theta. Bottom then becomes square root 4 minus, and if you square that again, it's going to become 4 sine squared theta. Okay, times then by 2 cos theta, d theta. Now, what I'll do, right, because you might be concerned about this 2 cos theta here, leave that as it is for a minute. So what I'm going to do is, I'm going to look at what I can get in that square root. If you notice in that square root, we can actually factorize out a 4. If you notice 4 is a common factor, so I can take out a 4, and if I factorize it, of course 4 times 1 will give me 4, and then that will be sine squared, yeah? Okay, times 2 cos theta, d theta. Okay, so you take another 4. What I hope you notice then, on the bottom, 1 minus cos squared, of course, is sine squared, isn't it? Sorry, 1 minus sine squared is cos squared. Yeah, because 1 minus sine squared is cos squared. Remember using that rule from C2, sine squared plus cos squared is 1. This then becomes, well, we've got 4 sine squared on the top. Square root that then, you get 2 cos theta. Okay, because if you square root, you can square root that single term, you get 2 cos squared, you know, 2, and that becomes cos theta. And you've got 2 cos theta then on the top. What you'll notice then is the 2 cos thetas cancel. Okay, so that goes. 2 cos theta divided by 2 cos theta is 1, and you end up having then 0 pi by 4 of 4 sine squared theta. Okay, that's what your answer becomes. And if you notice in the question, we get it in that format there, yeah? So k is equal to 4 in our case, right? And this says hence evaluate this. Okay, So hence evaluated. So we've got it in that form, 4 sine squared theta, and we've got to now evaluate it. Now what I would do next is I'd rewrite this as 4, take the 4 outside. Okay, that's how I'd rewrite it. And then you need to appreciate, you've got to integrate sine squared. And remember I did a video on that recently with sine squared integral. You've got to use the double angle rules. Okay, so remember the double angle rules. Okay, so we basically say, look, cos 2 theta is equal to, now it's sine squared, so we write that rule down, 1 minus 2 sine squared theta. Okay, if you rearrange this then, you'll have 2 sine squared theta equals 1 minus cos 2 theta. And take the 2 over, so sine squared then theta is 1/2, 1 minus cos 2 theta. So you're dividing that by 2. Then we substitute that in, right? Because that's what sine squared theta is. We substitute it in. So basically sine squared becomes that. And the half I can put outside, yeah? Or, you know, if you want to take your time on it, you can write half here and then the bracket, because that's what sine squared is. But I'm going to put the half outside, so you get that. And then we can integrate. Now 4 over 2 is just 2, of course. When I integrate 1, we get theta. Remember, it's in terms of theta. And when I integrate cos 2 theta, it becomes sine 2 theta over 2. Okay, using those C2 rules, C3 rules. Pi by 4 over 0. And then, last but not least, then it's a case of just substituting it in. So you put pi over 4, take away sine 2 pi over 4, all over 2. And then take away then 2. And you put this lower limit in then, 0, take away sine 0 upon 2. Okay, so this becomes then simply 2 pi over 4. I work them out separately, I would first, before you type it into your calculator. Sine 2 pi over 4 is 1. Okay, so you get that there. So that's what it is as a full answer in the complete form. All that becomes 0. And this becomes 0.571 if we to round it as well. It's good to have it in that form as well.